So good morning, everyone. Welcome to this session, the workshop IoT in Edge Computing Research and Standardization Challenges. My name is Georgios Karagiannis, and I'm the moderator of this session. And I'm as well the chair of the Working with Standardization of the Alliance for IT Innovation. And in my day-to-day life, I'm working for Huawei. This workshop in general started yesterday and discusses challenges and research challenges and opportunities for research and standardization in the area of IoT and edge computing, as well as standardization on the international scale. And as well, we are also discussing ways on how we can strengthen the contribution of the European research projects in standardization activities and standardization efforts. So that's in general the goal of this workshop. Before introducing the program, I would like to also introduce the co-organizers of this session, and you can see them here. Mr. Rolf Riemann Schneider. He's actually working for the European Commission in the IT unit, and he's responsible currently in coordinating the research innovation activities in a very important area that's actually called as from cloud to edge to IT for European data. And this is actually an activity that is included in the Horizon Europe program, Cluster 4, Destination 3, and it has an investment of 150 million for 2 years. And then I would like also to welcome Mrs. Anna Brekin. I'm not sure if I'm pronouncing the name well. She is a project manager at the Mandat International. She's actually involved in the NG-IoT project and has a lot of experience in Horizon 2020 projects in the area of IoT. And of course, also in standardization activities done in those projects. So I would like to give the floor and possibility to our session co-organizer to welcome you. Thank you. So Rolf, please.
Many thanks, Giorgio. Ladies and gentlemen, good morning. It's a pleasure to welcome you to this workshop. The emerging domain of edge computing will have a strong impact in the context of Europe's data strategy, industrial and green strategy, as well as to contribute to the Sustainable Development Goals and Europe's climate actions. Defining edge computing as a term, evolving market and a transformation engine for many sectors, I think it's an opportunity for Europe. However, looking at the IoT landscape, today 70% of IoT revenues are cloud-centric. At the same time, we know that 80% of data processing happens in the cloud. And consumer markets especially are dominated by a few dominant cloud providers. So, and there's a low adoption rate in cloud technologies, industrial sectors. So we see then a gap or an opportunity for Europe to reverse the trend, that 80% of computing will happen at the edge. And by 2023, more than 50% of all new infrastructure which will be deployed will be edge-centric. So that's why we believe there's an opportunity under Horizon Europe to develop innovation scenarios of ubiquitous data across the computing continuum. We see, on the other hand, for edge computing, there's also a risk, like we know from IoT, a risk for dilution of data and fragmentation of standards and interoperability at the edge. So contributions to formal and pre-normative standardization is important as one of the horizontal activities under Horizon Europe. The benefits and opportunities are amplified, achieved by economy of scale, of a geographically dispersed edge infrastructure of connected assets. But the opportunities are amplified if this infrastructure is based on common standardized components and modules and building blocks, software frameworks, and open APIs. So this is very important for our deployment programs like Digital Europe program, like infrastructure investments under the Recovery Research and Recovery Fund, or an IPCI on data. So today we are here to gather input from different sectors in an emerging domain like edge computing, but also addressing cross-sectoral perspective and applications. So I'm looking forward to your presentations, discussion, and a stimulating workshop. Thank you.
Thank you, Rolf. Anna, please.
Hi, thank you very much for this introduction, Georges and Rolf. And I would like to welcome you also on behalf of NG-IoT, in which we are tackling standardization matters, in which basically we are looking forward to finding mechanisms and pathways to support standardization efforts, bridging the gap across different sectors, verticals, the different administrative levels. Yesterday, in the last session, we did notice that there is a need to reinforce this convergence. There are different processes of standardization between regions across the world, and we are also noticing new emerging priorities in standardization. So there is a deep need right now to tackle domains such as B2B, which is at the heart of today's session, and discuss topics such as trust, interoperability, scalability, particularly in the industrial sector, which is, as Rolf did mention, very much at the heart of the preoccupations right now of the European Union, and also touches upon other parallel issues such as sustainable development goals and the EU Green Deal. So we are looking forward to hearing from you through your presentations. We have a very diverse panel of speakers, and we do hope that we come up with very successful and fruitful discussions. Thank you very much.
Thank you very much, Anna. So now I will show you, as I mentioned, a promotion slide, and that was asked by the ITA Secretary General to me to do that, so I'll do it. Actually, the Working Standardization has published last week 2 reports. So the first one is on edge computing, SDO Alliance and Open Source Software Initiatives Landscape. That was published on the 7th of September, and the other one, the second one, is IoT and edge computing impact on beyond 5G, enabling challenges, that is published on the 9th of September. So you can find information via the IoTI website, but as well the chat includes the URLs that you see here. So thanks. That's the promotion. I'm very happy that these reports actually are published. And I think very useful. And we'll start the promotion starting next week. Then I will actually share my the agenda, and also emphasize and also explain that this session, as I mentioned, is a part of a workshop, and the title of the session is IoT and Edge Computing Research and Standardization Convergence. And it's organized by NG-IoT, by the Alliance for IoT Innovation, and the IoT Forum. Some information regarding this session. So this session will be entirely recorded and published on the NG-IoT channels. Please, if you have any questions, please put them using the Zoom chat. I think there is also a question answer possibility, but you may use both. And please feel free to share your thought about the workshop on the Twitter, on the information, on the points that are mentioned here. Okay, so I mentioned there is this workshop that has 3 sessions. One session took place yesterday and today. There are 2 sessions. So this session is about the second one that I mentioned, European Standardization in IoT and edge computing for industrial IoT, telecommunications and automotive domains. So this is the session that we'll be focusing on today. And then at 2 o'clock p.m. Central European time, you can follow the third session on also European standardization in IoT and edge computing, but then for home, living, energy, mobility. So this is a B2C, while today we'll focus on B2B domains. So let's go through the program. We have done the welcome, and then the next part of the session is an important one. It's about presentations from our significant speakers, and they will actually the presentations will focus on 2 main goals. So identify the gaps and priority needs of the industry with regards to IT and edge computing standardization for industrial IoT, telecommunications, and automotive domains. And then also to identify opportunities and ways on how to enhance the contribution of European research projects to upcoming standardization IoT and edge computing domains. These are the 2 main objectives that the presentations will focus on. And I would also like now to introduce our speakers. So for starting from the top left, Ms. Nurit Sprecher from Nokia. She's actually working and leads the Nokia standardization strategy and activities in the areas of management and automation, visualization and application enablement. Welcome, Nurit. You may put your video on. I'm not sure if you,
I'm here. Yeah.
you have done it already, because I cannot see that. Welcome. Then I would like to continue with Mr. Christer Boberg. He is director of the IoT and cloud technology strategies at Ericsson. Welcome. Following with Dr. Ronald Freund, head of the department of Fraunhofer Heinrich Hertz Institute. And Ronald is as well representing the IoTI Computing Continuum Task Force, and as well the HCIG F5G. Welcome. Then continuing with Mr. Juanjo Hierro, is Chief Technology Officer at Fiber Foundation. Welcome. Then Mr. Martin Bauer is Senior Researcher at the NEC Laboratories Europe, representing as well the Fiber. Then following with Mr. Thomas Hahn, he's BDVA President and working at Siemens as Chief Expert Software. Welcome. And Mr. Klaus Wachter from Siemens, for working for working as Global Standardization Manager at Siemens Smart Infrastructure. Welcome. So welcome very much, and I will continue now with the program. So we'll have a second panel, and it will be the second panel discussion. Actually, the speakers will also be part of this panel, and in addition, Mr. Gael Blondel, that's representing Eclipse, will and is VP Ecosystem Development, Eclipse Foundation. Welcome. And then we have Mrs. Ruta Sofia, and which represents the CSA EU IoT project, and she is as well the head of the Industrial IoT Competence Center at Fortis. So we'd like to mention that the speakers of the presentation of this panel will have 10 minutes for each presentation, At the last minute, I will actually interrupt, and sorry for that, to let them know that they will have one minute to conclude. And for the panel session, so then Mr. Gail Blondell and Mrs. Lourdes Sofia will also have 5 minutes each to introduce certain topics, and then the same will take place. I mean, the last minute, I will ask them to. I will inform them about the fact that concluding remarks needs to take place, and then we'll have wrap up and conclusions, and Mr. Rolf Riemenschneider actually was very kind to would provide conclusions for that part of the session. So now I would like to start the second part of the session, and I would like to give the floor to Mrs. Nurit Sprecher. Nurit, please. Need to unmute yourself.
Yeah, minor thing. Yeah.
Yeah.
Thank you. Okay, so first of all, thank you for the opportunity to present our perspective in this important conference. Let me start sharing, if I find it, okay. Yeah. Okay, so what I will, let me just take this one here. Okay. So what I will present today is a little bit our perspective about multi-access edge computing, which we actually refer to as the common and extensible application enablement platform for new business opportunities, including the IoT. And when we talk about edge computing, it actually offers the cloud computing capabilities and the IT service environment at the edge of the network, constituting a powerful catalyst for innovation, unparalleled user experience, and lucrative business opportunities. The edge environment is characterized by proximity, by ultra-low latency and high bandwidth, and IT economies of scales can be leveraged, allowing proximity context and agility and speed to be used for wider innovation, which can be translated into unique value and revenue generation. We can have, for example, interactive and delay-sensitive applications such as gaming, augmented reality, or indoor navigation located in close proximity to the users and benefit from the increased responsiveness as well as maximize the speed and interactivity. We can have robust low latency where we have a high volume of data messages to be delivered with minimal delay in near real time. And can be ensured for example, critical communication, for example, in industrial environment. Real-time analytics can be performed at the point of capture, and corrective actions can be instantaneously taken locally. Furthermore, Edge platform can provide insight of real-time network and context information that can be used to optimize the application, can optimize the network and the service operation, and proactively maintain the customer experience. So, for example, if I'm aware of the real-time capacity available at the radio downlink interface, a video server can intelligently maximize the utilization of the precious radio resources and accelerate the video delivery, improving both the video quality and eventually also the user experience. So we believe that unparalleled quality of experience, contextualized services which can be tailored to individual needs and preferences can be provided by the edge. And of course, we have the use cases, of course, are unlimited and just up to the sky. If we think about the deployment options, by the way, of the edge. So MEC can be deployed at hotspot to support zone applications such as special services in stadium, exhibitions, malls, enterprise campuses, etc. It can be deployed in metro aggregation sites and basement hotels to support city-wide applications such as video analytics, used across the city, or IoT applications used to monitor smart city infrastructure, just to name some examples. And it can be deployed in a distributed data center, like a Cloud Run, or in specific deployment pattern, as well as in centralized data center to support network-wide applications such as V2X along the roads. If you think about how we actually look at the MEC, so the opportunity is really the intersection between the CSP environment and the industries and vertical environment. So if we think about the edge telco or private network, which can be best-in-class radio access network with real-time radio optimization, which is enabled, for example, by the RAN intelligent controller, we actually create here a service environment which can be a focal point for operators to collaborate with enterprises and application developers, providers, and exposing MEC value-adding APIs to the different industries to take advantage of this context information. So this is actually a service environment for enterprise verticals and application ecosystem. We look a little bit into the standardization perspective. So the foundation and where we are, so the foundation for the edge computing was created. And we have a fully standardized solution already to enable application in distributed cloud, which were created by ETSI, Multi-Access Edge Computing, and Suite GPP. So ETSI, for example, has developed an API framework to deliver services which may be consumed or offered by locally hosted or remote authorized applications. It allows you to register services, to announce them, to discover them and notify them. It allows you to authenticate and authorize the application providing or consuming services, and all the communication support with all the patterns like query and response and notification. It also provides a set of principles and guidance how to develop and document APIs inside ETSI, but not limited to ETSI. And the idea about this is to ensure that we have a consistent set of APIs to be used by the developers. We believe that having a common practices and APIs which are designed to be application developer friendly and easy to implement are very, very critical to stimulate innovation and foster the development of edge applications. And the work, by the way, was inspired by best practices in the industry. ETSI also has developed a set of specific service-related APIs that can be exposed to the applications, providing network and context information. The different set of services may be applicable at different locations. So services include, for example, like network radio information. Right now, ETSI is working on a 5G abstract information, really to hide and abstract the complexity of the network, and that the application can use it with little or even no understanding in the radio itself. Radio network itself, wireless LAN information, fixed network information, location information, UE identity information, V2X information, IoT information, and you can support bring your own service, and it supports any service that is brought by third parties. And also ETSI has provided the management, orchestration, and mobility related APIs to facilitate the running of applications at the correct location at the right time, based on technical and business parameters, and also to ensure service continuity. So if, for example, there is a handover event which has some impact on the requirements of the application, so the application may be relocated to another edge cloud. And the whole thing about ETSI, it enables the myriad of use cases across multiple sectors, as well as innovative business opportunities. What we have done also was to enable the MEC implementation already in the design of the 5G architecture, very from the beginning of that. And the 3GPP 2 referred to the MEC as an application function and provided the support to enable the selection and relocation of the UPF function to allow it to run also at the edge and to provide the local breakout, to influence the traffic routing, provide the mobility event from SMF such that we can trigger the handover in time, and to have also concurrent access to local and the central DN. There are a lot of papers that indicate how to utilize these enablers and use it and integrate MEC into the 3GPP environment. For example, Nokia has written a white paper on enabling application at the edge of the 5G network, and also Etsy has written a white paper about making a 5G network. So all of these are accessible, and you have the links there. I just want to mention that the Etsy community is growing in a very healthy state, and we have almost 120 members representing the different players in the value chain, including operators, technology providers, IT players, industries, application developers, etc. So this is really continue to grow, and this is a very good message to the industry. So what MEC provide us is provide us the...
One minute, sorry.
Okay, so okay, I'll need maybe a little bit to extract, but I'll try to accelerate and have the slide so you can actually take it. MEC provides the foundation for openness. It provides a common application platform and enable new classes of services. It can run on every cloud and in every deployment option. I will send it to you. You can see it later. Etsy MEC is also working to attract the application developers, that they understand the value of the APIs, that they understand how to use it, that they understand the value that they can have by developing applications. And regarding the harmonization, I think this is something very, very important to touch. So a lot of, the foundation were created by Etsy MEC, and then the integration in 5G. But then 3GP started working also on mobile edge application architecture with a more UI-centric approach, that the UI is edge aware. And what we actually did is to create a synergic architecture that indicate how the different components from the Etsy MEC and SE6 can be combined to support different deployment options. So this is a white paper. You can look at that and touch it. Also, 5G is leveraging the MEC as a key building block for the V2X services. 5G ACA is starting analyzing that. And what is also important is that the operators has defined their operator platform GSMA, and the MEC is well positioned to satisfy these needs. And the GSMA also asked to put some additional effort in Etsy MEC and in 3GPP to support their further requirements. Also, the SMOSA forum has touched this and referred to that. This is the Synergic Architecture. You can look at that at the white paper, and you have all the information there. Maybe just last 2 slides, and I finish by this. From Nokia perspective, what we are actually doing, we are bringing together the RAN intelligent controller that we are doing in the ORAN and the MEC platform, and we put them on a single platform to make the application network aware and the network application aware, to be able to customize and optimize the network based on information coming from the applications, and then allow the application to optimize themselves based on information coming from the network. So we have a common platform for the RIC applications and for the MEC applications, and we actually, and they are running on infrastructure independent, and it's containerized platform for innovation and enabled by AI ML services. So this is something that I'm happy to elaborate more, of course, later. And just the epilogue from my side, and I will conclude with that. So there are vast business opportunities at the edge. MEC is coherent with the openness ambition for innovation and growth. It provides common API framework for third-party plugin and open APIs for data exposure and programmability. It's aligned with the overall cloud transformation, and it's a natural element of 5G. It's a key enabler for IoT and mission-critical vertical solutions, and a focal point for collaboration. The fundamental MEC specifications already, Etsy MEC is widely recognized as the leading SDO for application enablement and edge computing. It's well positioned to satisfy the needs of operator platforms and help monetizing the operator networks using the APIs. It's flexible and extensible. The number of edge initiatives has considerably grown, and what we are doing is really to harmonize, and we believe that alignment and leverage across the industry should happen in order to ensure adoption and acceleration of time to market.
Thank you. Thank you very much, Nurit. It was very clear, very important information, I think, about MEC and also about some strategy that Nokia is following in this area. Thanks very much. Then I would like to continue with Mr. Christer Boberg. Christer, would you like to take the floor? Yeah, please. We cannot hear you. I don't know. Christer, you are muted. We cannot hear you.
You hear me now?
Yes.
Great. And you see me as well, I hope.
I see you.
And I will even try to share my screen here. So
please.
Let me do like this. All right. Sorry for the issue here. I hope you see my screen. So I will try to be on time. Thanks for letting me present today. The angle of this presentation will be from an outside-in perspective, and I will focus on the needs from global automotive actors that don't necessarily have a focus on Europe. In fact, rather the contrary. As when we look at the connected vehicle industry, it's a global industry with some exceptions, and the way for all the way from the vehicles to the OEMs, they are technology providers, networks and clouds. I mean, Europe is a key region, of course, for automotive, but as we've talked about also in previous presentations, there will be a number of alliances going forward, and we do believe that it's not wise or even possible to look at what alliance will be successful in the mission it has, but they will make a difference. And I think the real value comes from the fact that companies are getting together and form alliances to solve certain problems, and these alliances will come and go. Just an example, when we look at the interesting thing of connected vehicles and automotive, there is quite a large number of activities ongoing, and most of these listed here, by the way, are based in Europe, driven from European perspective. That could lead to fragmentation and complexity, but it will, of course, also lead to broader innovation. New ideas, solutions will come in place that bring value to automotive and connected vehicles. There is, however, a need for alignment of standardization, technology choices, and best practices. So for this purpose, we do believe that it's important to make sure that there is a common framework as a base for these industries, and not only for connected vehicle as such, but a broader industry, because we can't, of course, build different solutions and have different deployments for different industries. And it's important then that we have SDOs such as 3DPP and ETSI to drive these horizontal strategies. And what we say is that these alliances, such as ACC, should put new requirements to the SDOs, rather than defining their own, and perhaps more important, that we decide upon what we call blueprint on existing standards. There are a number of possibilities of using the standards. So what we say is that we need to agree to common framework and use it for these standards for both generic and specific cases, and that these can be deployed by all the service providers needed. And connected cars, edge compute for connected cars is one example, where there are many different ways to find the proper solution, and then these challenges and solutions should be horizontal in a way that it's not industry specific. Also, many of these features, many functions are provided by multi-actor solutions, and at least for the global multi-country, it's important that these alliances put requirements also on providers, connectivity providers and cloud providers, so that these become available and adapted on a global scale. The risk otherwise is that or rather, one thing to remember is that we should have a real problem domain when we start to define standards and best practice, and should have preferred some business relation and certain use cases to look at, because otherwise we believe that there is a risk that we standardize something that is maybe not really needed in the time that we think about, and it's also a common risk that alliances and standards continue after we have solved the original problem. Then I would talk a little bit about connected vehicle and connectivity from an Ericsson perspective. It is often so that problem domains are defined by the industry and company providing the service and owning the end user business. And when we look at the and also it's important that they are in the driving seat, and there may be very different and disparate requirements within an industry. And just looking at connected vehicles and automotive is one such example. So it's really key that we have these standards, that they are global and open. And Europe is a key driver, of course, but it cannot create its own standard solution, and because that will risk becoming stale or even hinder evolution. Next slide. Some issues or challenges that we see with the connected vehicle. I will not go through this in detail. It's for reference, but these examples are important, and they relate both to standards, technology, and business. And just as examples, obviously for connected vehicles, one of the absolute key issues and key challenges relate to the coverage as such, because the evolution of connected vehicles often lies within the fact that there is a connectivity. Yeah, looking into this, there are many things that we believe we have to look at from a standards perspective, but also from a deployment perspective. I will come more to that later on, and I think that's something to discuss also in the panel. So going back to the problem formulation, I mean, AECC is one example where we have a problem domain with clear use case to support. In this case, use cases are originating from a Japanese automotive OPM, but with a very global market. And in AECC, you have all the global industry players from different regions and different type of industries that comes together to provide solution and creating guidelines for what we call an end-to-end chain to work. So our main focus here is, of course, as the name indicates, edge compute. But as you saw in the previous picture, there are many topics that we look at when it comes to the connected vehicle to really thrive and work. So again, I mean, success comes from being open and a clear problem statement. So, but it also means that it must be practically possible from a technical and business and also regulatory way to use these recommendation standards. And it requires that we have the right infrastructure, both defined and deployed on scale. I mean, it's not enough, of course, to support a global industry with solutions that are fragmented on geographical base. So we should remember that when we talk about European standards and recommendations. So we do, of course, understand also from AECC, which is a quite small organization with a quite limited problem domain, that we cannot reach our goal by working internally only. And we are related to the discussion today. We are very open, of course, and welcome to work both with other companies outside of AECC, academia, research projects, and regulators to bring this recommendation to commercial level, which is our goal. And we have already examples in AECC that we have used our technology recommendations to work and make proof of concepts together with the companies outside of the AECC members, so to say. Then I would also say that, again, emphasize that proposals that we make has to be provider agnostic. and open for anyone to implement. And this reference architecture must be openly published as soon as possible to get the right reach and scale. We are talking about cloud players and cloud solutions. I think we will talk more about it in the panel, but it is really key that we have what we call multi-provider solutions to avoid lock-in effects and specific solutions that cannot be replaced when needed. So finally, I just want to say that looking at this ecosystem, the situation discussed before, automotive is maybe not the only one, but it's most obviously for the connected vehicle, the global challenge. It is a global challenge. Europe is part of a global ecosystem, cannot drive its own standards, but it can drive the agenda for standards and recommendation. We do believe, and that has been stated before, that an absolute first step is to build out the infrastructure so that we have connectivity and cloud solutions, including 5G and edge, that can be used. And considering the size of the European region compared to other markets, it has to be consistent and open within Europe. It has to remove, I mean, one great example from Europe is the removal of the roaming fees and common rules for data sovereignty and privacy. But that has to be on a global scale, and it has to work in a way that is effective also for the connected vehicle when we look at the big amount of data that will be sent and handled through the connected vehicles. We also believe that regulations that promote openness and collaboration in Europe and other markets is important. Regulations that block innovation infrastructure build out will heavily impact our revolution. We want to also say from both Ericsson and
1 minute, less than 1 minute, and then
Sure.
also please one question from Rolf. What is the relation of satellite here? Go ahead, please.
I mean, if you look at the ACC, it's not access bound as such, but right now the main focus for the ACC and the connected vehicle is to make sure that we have a consistent and standard way of using the global cellular network, cellular coverage. However, satellite is very interesting and high on the agenda for connected vehicles and ACC as such. Again, I just want to say that the last thing that Europe has a very strong industrial ecosystem in many segments, and I really think that Europe should be able both to define the problem domains and also be the driver of the evolution. So again, these solutions cannot be Europe specific, but we could drive the agenda from Europe and the industry actors in Europe. Thank you.
Thank you very much, Krista. Very clear. Thank you very much. Then I would like to give the floor to Ronald Freund, please.
So, Giorgio, thank you very much for your invitation. Can you see my slides?
Coming, yeah.
They are coming, okay. Okay, it's a pleasure for me to talk a little about computing continuum requirements on IoT, edge computing, especially with a focus on optical communications. So my name is Ronald Freund, and I'm heading the Department for Photonic Networks and Systems at the Fraunhofer Heinrich Hertz Institute in Berlin. So I think in the coming 10 minutes, I will focus mainly on two topics: the ETSI F5G activities we are supporting and the AI-OTI task force on computing continuum. And of course, I will conclude with a short summary. So Fraunhofer Heinrich Hertz Institute is one of the more than 70 institutes of the Fraunhofer Association, and business fields are especially the development of technologies for mobile communication systems, 5G, 6G, We are here very active in the 3GPP standardization. Another topic is the development of video codec H.266 or H.265. So here we are also very active within the ETSI standardization. And we have a lot of activities on system and component development. We have our own medium phosphide fab to prototype high-speed components for the next generation of photonic and quantum communication systems. So with the context of edge cloud, we are part of the Fraunhofer environment. So the last years, Fraunhofer established a comprehensive testbed in Germany, connecting the different Fraunhofer institutes. And this is going to be a real-life laboratory for politics and for the industry. So we started, of course, with cross-international, cross-institutional projects. We are going to have European and international project based on this infrastructure. So in Berlin, we focus on the industrial IoT. So together with partners, different Fraunhofer institutes in Berlin, we initiated the Berlin Center of Digital Transformation. And especially this center deals with the investigation of Industry 4.0 use cases with respect to the real-time digital production twin, for instance, real-time supervision, real-time video analysis, but not only with a focus on software, but also with a focus on new hardware accelerators like computer acceleration, neuromorphic computing is here the buzzword. And within this ecosystems, we are taking part within different standardization activities. One of the standardization activities is F5G. So I would like to introduce these activities a little bit to you. It's located in ETSI, and this slide shows you the evolution of the wireless and wireline communication standards. On the top line, you can see the wireless technology up to 5G, but each of the wireless technology requires a very powerful wireline technology. And for today, of course, we can use passive optical networks and also the Wi-Fi 6 and Wi-Fi 7 technology to support the 5G mobile communication, for instance, for connecting the different sites or to upload the data from 5G. So in this standardization activity, the goal is to have fully fiber connectivity, not only of the homes, but also of the desk and also of the machines. And we think that's very important because the fiber-based technology can address and support a couple of KPIs which are very important and which are shown on this slide. Especially we think that energy efficiency is very important, which can be addressed and can be improved by using fiber communication system. We think that also the high speed, reliability, and the availability of systems is very important to support not only the 5G communication standard, but also the 6G or beyond 5G mobile communication standards. So actually in this context, we are addressing new use cases, and we think that especially the passive optical networks are very important to support edge cloud infrastructure, not only in Germany, but worldwide. And we are seeing that this technology moves from 10 gigabit per second today to 50 and 100 gigabit per second. And also it's important to have a very high-speed communication between the different sites. If you address, for instance, location-aware services, and here 800 gigabit per second per wavelength, or even higher, are very important. 800 gigabit per second you can now have with a power consumption of 22 watts. But it's not only about infrastructure. So the main vision is to have 0x experience in converged networks. That means those networks have to be simple for the users, and the complexity has to be tackled by the providers. And within this context of different applications as a service or as a platform, it's very important to address this zero weight, zero touch, and zero tuple experience. Having a look to the computing continuum, or having a closer look to the infrastructure, we need then, of course, you have to address the data flow, and you have to put the right communication power at the right point. So usually the data flows from the endpoint over the X to the core. Then you have, of course, your clouds and back. And we think that, of course, the raw data has to be analyzed at the endpoint and, of course, at the edge. But the connectivity between the endpoint, edge, and the core is very important. And therefore, we think that passive optical networks or the optical communications, of course, will play an important role in the future. So that's why we are supporting the IEOTI activities within this task force to study use cases with respect to the computing continuum. And this activity started mid of this year before the holiday seasons, and we already selected a couple of use cases which are shown on this slide with respect to Industry 4.0, where we would like to investigate the requirements on the optical transport network, which are shown here, for instance, for the cloud-based visualization inspection use case, or the cloud-based control of automated guided vehicle use case, with respect, of course, to latency and bandwidth and required jitter, for instance, for time-sensitive networking. So the status of this work is, as I mentioned, that we have selected the use cases. Until end of September, we are going to finish the first chapters, use cases and requirements, and we would like to come up with a first draft by the end of this year, not only addressing use cases and requirements, but also addressing, for instance, the KPIs of the network, connecting edge computing platforms and cloud. We would like to have a look to the orchestration of the computing continuum, as well as we would like to address the security with respect to that topic. That brings me also to the end of my talk. I think that the networks are experiencing an explosion of new services, and there's a need to have high bandwidth, low latency, and edge computing capability at the right point. So the computing needs to be fast, efficient, secure, and it requires to be allocated as close as possible to the data source, as I explained in my last slide. So actually, there are a couple of challenges, especially when we have to collect data from different sides for near real-time decisions. And then, of course, we think that the optical transport networks is an enabling technology to support those use cases. Thank you very much for your attention.
Thank you very much, Ronald. Thanks, very clear. Also on the activities in IoT and the ETSI AGF 5G. Thanks. Then I would like to give the floor to Mr. Juanio Hierro. Can you please stop sharing? Yeah, thank you. Juanio, please.
Yeah, hold on 1 second. So I will switch on the camera and share now my screen.
Yeah, coming.
Yeah. All right. Do you see the screen?
Yeah, maybe you can put it on the presentation mode. Yeah, thanks. Coming.
All right. Well, I would like to start with elaborating a bit on something that I believe is pretty important in the discussion towards the strategy on standardization, which is a bit understanding the economics behind the creation of standards following an open source approach. And here, I wish to bring a reference to a law that was formulated some time ago by Clayton Christensen. Many of you probably know him, author of The Innovator's Dilemma, about the law of compensation of attractive profits. And essentially what that law states is that when attractive profits disappeared at one stage in value chain because a product becomes modular and commoditized, then the opportunity to earn attractive profits with proprietary products will usually emerge at an adjacent stage. And what that means is that companies can really join forces towards commoditization of products and services. And here is where standards and using an open source approach can play a role. And with this play the strategic decisions towards where we want to move the money in the whole value chain. And this is something about which I believe Europe has to play really smart. Part of the transferred profits may be also transferred to end users through price discounts and therefore activating market demand. Yeah, let's see if I can. I don't know, it's not moving. Yeah. Now all of them. Okay, and here today we mostly focusing on IoT edge computing, and well, IoT is not as such a goal. It is technology is a means that is relevant for something which is more holistic as the development of smart solutions. And smart solutions, generally speaking, can be designed around management of a digital twin representation of the real world, which is constantly analyzed and processed in order to automate processes or bring support to smart decisions. Digital twins being a digital representation of a real world entity characterized by attributes, the properties, relationships, values of attributes, which may change over time and typically have a location. But IoT is there, and what concrete IoT protocols are used to bring the values of certain of these attributes is actually irrelevant. That should be transparent to application. What I'm trying to mean here is that the battlefield is really in the area of digital twin, where essentially the benefits of standardization will be better captured. Actually, this becomes more evident if we think a little bit where European strengths are in the industry. From my perspective, at least, Europe is capable to perform rather well at two levels. Solution integrators, we have quite important relevant solution integrators. I include here even the telecom providers, but also we are doing quite well when we talk about IoT device manufacturing, both at hardware and software level. Where we are not that strong, we have to confess that, is when we talk about cloud platforms. And this is what is getting dominated by the hyperscalers and which have evolved from the more traditional independent software vendor sector, but we are not really there with big players. So therefore, if we try to apply this Clayton Christensen's law, I believe we should focus on commoditizing the software for the digital twin platform. And three essential elements for standardization were to focus. One is the standard digital twin API to access digital twin data, the common data models associated to the different digital twin classes, and what could be the framework that you are going to use for identity and access management, where there will be an exchange of digital twin data across the different layers of the architectures across different organizations in a highly distributed architecture. That is where the focus of our standardization activities in FIWARE placed. As many of you know, if we talk about the API, we really believe ETSI NGS-ILD brings the potential to become this digital twin API we are looking for commoditizing the digital twin platform, as I was mentioned, a simple yet powerful API. Still some features to support, and we need to work if we are looking towards edge computing and highly distributed architectures. These are current activities going on and discussions within ETSI. We welcome everyone to participate, and certainly there is here an opportunity for research projects to bring the inputs, the experience towards evolving the specifications in the right direction. Second element is the smart data models. As I mentioned here, I would like to highlight the smart data models initiative we launched some time ago, and then is gradually evolving and growing as we speak, with many organizations contributing, many projects contributing to the definition of data models in multiple application domains, ranging from cities to energy, environment, manufacturing, and not trying to reinvent the wheel, actually leveraging existing standards when they exist, like it could be SAREF or IEC SIM in energy, but creating something that otherwise was missing, like definition of JSON and JSON LD structures coming as a mapping from those standards that can be used with the API, and therefore support portable solutions. The third elements, or the third axis on which, of course, think about how to perhaps not define standard, but check how to integrate those standards, are those elements regarding security and trust. Security and trust, not only within the architecture of an existing application, but also when we talk about data exchange, about between applications within a given data space, applications coming from different organizations. Here, identity and access controls standards need to be defined for handling identity and access control at organization level, also at the level of users of applications within a given organization. And the challenge is to integrate some of the existing or emerging standards. I guess you are somehow familiar with these, some of these acronyms. OAuth, OpenID Connect is a self-sovereign identity, distributed identity, XACML. All these elements have to be put on a cocktail and drive the definition of what are the kind of security and trust standards in development of digital twin-based applications that can work on highly distributed architectures.
1 minute, sorry.
Yeah, that was actually the last slide. So I'm doing pretty well with time, with just the conclusions remarks. First of all, we should adopt a strategic approach when defining the strategic direction we want to take and where to concentrate the efforts. We need to commoditize those elements in the value chain where Europe is not that strong, and really play with this way that Clayton Christensen's law works, and therefore transferring attractive profits to these areas where we have strong European actors. We see the battlefield around the topic of digital twins as what is going to be, at the end of the day, connected to IoT and also edge computing. We need to be in the forefront how to define digital twin-based architectures that are capable to run on the edge and not just in the cloud. There is a good basis to rely on with the work in ETSI through NGS-ILD, with the work in Smart Data Models Initiative. And there is an opportunity to make progress leveraging Horizon Europe and Digital Europe programs, elaborating and evolving how digital twin architectures can run on the edge and supporting highly distributed systems, and how all this cocktail of security and trust standards can be really combined. Thank you very much.
Thank you very much, Ronel. Yeah, very interesting talk about important topics that that Europe could lead, and digital twin is one of them. Thanks very much. And then I would like to give the floor to Martin Bauer. Please, Martin.
Okay, one moment. Share the screen. You see my slides?
Yes, please.
Okay, so then we are ready to go. So my name is Martin Bauer. I work for the NEC Laboratories Europe in Heidelberg in Germany. I'm partially working on European research projects, partially on standardization, currently primarily on ETSI SG-SIM, standardizing NGS-LD. I'm also working on FIWARE. Previously, I've also worked on 1M2M standardization, and I'm also the co-chair of the AITI expert group on semantic interoperability. So today I'm going to talk about digital twins at the edge. You'll probably see some, well, maybe not overlap, but maybe similar things, maybe from a different angle than what Juanjo presented. Okay, so regarding use cases, we have done a use case both in the field of digital factories. So what you see here, developed a digital twin as part of the MIDI project, where we used digital twin to predict defective products before they are finished, saving time, energy, and material that would otherwise be wasted. What I would focus on a bit more is where we looked at digital twin regarding autonomous driving in the autopilot project. So have a digital twin for a real car, and observation is that real car has a limited view. Would for some things be good to have access to history, 3D model, and also enable the interaction with other digital twins, and not just those, but also the car is in an environment. So if you have a digital twin of the environment, you can access all of this. And what do we want to have? We want to understand better the current situation the car is in. We want to predict possible future situations to already know how to potentially react, and to react early. And then recommend or even do actions, actuations as a result. Good. Looking at the model, so we have clearly the physical twin in the example of the car, and information is captured. That's basically the data twin that's stored. And to realize a functionality that I've mentioned, we need to monitor and analyze that. That's the reactive twin, providing feedback. We want to know what if under different future situations. So we need to be able to do simulations. Based on that, decide and potentially do actuation on the physical twin, either directly or giving a recommendation to a driver or something like that. Then there is one more aspect of a twin, maybe not so much in this scenario, that you can build a twin sometimes even before you build the real thing, to test to simulate, to predict if it's behaving, and then as a result of this predictive twin build, the physical twin. So we have these 3 different options. So now regarding standards, what do we already have? If we look at the data twin, we need to model the information, and as Juanjo already introduced, there's the NGSILD standard that on the one hand has an information model, which on a high level is shown here. So it's a kind of the meta model underlying the NGSILD that is the basis also for the API. So you have an entity, and entities can have IDs and types. Entities can have properties with values, and entities can have relationships to other entities. Now, what kind of types exist? That's a data model. Smart data models were also already mentioned by Juanjo. So in this use case, I may have a vehicle. I may have relationships between entities, vehicles, one being in front of the other. A property may be speed. So a very simple part of the model could be, okay, this car is in front of the other car. It has a certain speed. The source is the speedometer. But I may also want to keep the whole history of this, and I may link to other information. Maybe a 3D model is not directly represented in NGSILD, but I can definitely point to that and have that stored somewhere else. Now, coming to storing that, we see, okay, we have local things. Maybe we need to decide things locally, and this can be handled on the edge. So you may have a broker on the edge that handles the dynamic aspects of the twin that enables minimum response times for critical aspects. Then you have more bulk data, history, simulation models, and so on that may be big and should be stored in the cloud, where you also have processing resources. So you may have another broker and history there. And the interesting thing is, well, you can federate these 2 together. So you can have applications or these processing services that can access both through the federation broker without having to know about the distribution. So NGSILD API enables building such systems. And our broker already supports that. Now coming a bit more to the edge. We want to implement these things, and partially also at the edge, especially if we want low latencies. What we need is to be able to dynamically deploy processing also to the edge, and for that we have developed Fogflow, which is an open source FireWire generic enabler. A cloud edge orchestrator that can serve as a framework for digital twin processing. And the idea here is you can first create an abstract service topology, saying, okay, first I need to do some processing in A, then that's input for B and C, and then the results of that are again processed in B. So purely abstract. Then in a concrete way, I say, okay, this is what needs to be deployed in a certain real situation. So in real situations, I have particular sensors, for example. So I need to instantiate my abstract topology, and I may have multiple instantiations, so A1 and A2. And then I need to see, okay, what are my requirements, and what, according to what should I optimize basically. So in some cases, things may have to be fast. In some cases, a lot of data is involved. So local processing may be needed because I may not have the network to fast transmit this. So this comes in, and then this abstract based on this abstract plan, I can decide how to best deploy that in different edge nodes or in the cloud. Good. So looking at that, what do we already have? So we have, as existing standards for the modeling, we have the NGSILD information model, and as Juanjo mentioned, there are already a number of smart data models building on that out there that decide concretely on what types of entities there are and what properties and relationships they can have. And for the storage and access, you can also do that in a distributed way. You have the NGSILD API builds on this information model. So you can specify what kind of entities, attributes you're really interested in, and get exactly those back. Also geographically scoping these or so. So also maybe commenting on something that was mentioned yesterday, saying, okay, that's a local standard for Europe. In US, they use MQTT. I don't fully understand that, because what we have here with NGS-ILD is not the same level and it's not doing the same thing. Our main binding currently is HTTP, but we are also looking, for example, at doing an MQTT binding. So this is clearly something else on top, and MQTT doesn't have this kind of information model, doesn't have this kind of query language, so it's really not the same thing. Good. What are gaps, opportunities, and prototypes? We need to do processing and orchestration. We also want to be able to reuse and plug and play, so be able to do monitoring, analysis, simulation, planning, and we need to do this some kind of orchestration. For that, we have a prototype showing how that can work. So there may still be things to do. You can already start building what we have, but you can already also go a step further. Actuation, you can do some very limited actuation with NGS-ILD as it is, but we're also discussing to extend that to make actuation more as also an explicit part of NGS-ILD. You want to have, in the scenario that we had from Autopilot, maybe the interaction between twins, between different cars, between the cars and the environment. On that level, maybe there's also something needed on top of that. Okay, so that's the core. I'm not sure. I seem to be doing fine with time. I added
please
maybe.
conclude.
Okay.
Please.
Maybe very quickly, as also maybe preparation for some of the other discussion. If you look at NGSI, it's really an evolution. So really, it was first developed before 2010. There were prototypes developed in some European projects. Then NEC and Telecom Italia at the time created the context API based on these results in OMA. So there was a first standardization activity. Then that was really the context standard that was available. So Fireware project took it, and so okay, still things need to be done. There wasn't a proper binding, so it evolved in the project itself. And out of the Fireware project became the Fireware Foundation, Fireware open source community. So it became the central interface of that. And based on that, we said, okay, we need to bring this back to standardization, because, well, it's nice if you have one implementation and people can use it, but that's a kind of a lock-in situation. Also, there was not really a good specification that could be easily implemented by others. And you need that for good interoperability. So that's why we then said, okay, let's go back and do that. And also there were more things we wanted to do to evolve this, to make this fit for the future. So now we have something there that can also now be a good basis for modeling digital twins. Yeah, that's it.
Thank you very much, Martin. And I see comment from Gael on the NGSI-LD MQTT that he says they can work together well. And MQTT is more likely to replace HTTP in your use case, using NGSI-LD to describe payload, and MQTT makes perfect sense in my opinion.
Yes, I perfectly share that. So on our roadmap, we have to create a full binding. We have at the moment the possibility already you can do subscriptions, and instead of HTTP notifications, you can already get MQTT notifications, but it's on our roadmap to do a full binding to MQTT, for example, as one M2M also has a full binding to MQTT.
Thank you. Thank you very much, Martin. And now I would like to give the floor to Mr. Thomas Hahn. Thomas, please.
Yeah, a warm welcome from my side. Many thanks to be part of this session. And hopefully you can see my slide now.
Yes.
and hopefully now it's working. Okay. Very briefly about the topic, you know, when you're speaking about digitalization, you're speaking about interoperability, and interoperability needs global standardization. I think this was also highlighted by the speakers before, but of course we can influence this with our domain knowledge. This is somehow what is driving me in as a person and active in different communities. Briefly to my side, I'm at Siemens, so I cannot neglect the history or also some kind of manufacturing background. I'm a vice president of the OPC Foundation. I have one slide inside only to show the link between MQTT, how the companion specs or the modeling for machines can look like. And last but not least, and this is where I'm speaking today, I'm president of the Big Data Value Association, because here we are covering somehow aspects data value, like the name is, like its name written, from data quality, standardization, industrial AI, up to trustworthy AI topics, which we have to look inside. We are around 230 members, and for sure we have a working group regarding standardization, but again here on data value aspects, what is our home turf is, and incorporating this with, for example, Senelec, EEC, and the other respective topics. But let's now start, because it's somehow about IoT and edge computing topic. Some of the words or topics are addressed before, but what I only like to share is, and here, like I said, I cannot avoid to have my history or where I'm coming from. When you speak about an edge environment, edge or cloud continuum, I think Rolf mentions this also regarding the IPSAI, then we have to look where we make the deployment. Is it close to the field with the respective standard? How we get the portability to other higher level, and how is to the cloud. So we have to speak really about an cloud edge continuum with all the respective standardization needs from the pure communication aspect. You know, the pure communication is wrong. The communication aspects with new communication protocols like 5G and 6G. For example, the 5CR is mentioned, which also gives some kind of really deployment in the on the shop floor up to the let's say to the cloud continuum. But here again, looking where we are doing this and then looking at this, because you know I want to give you some kind of food for thoughts regarding the standardization topic. I just added before this slide because Rolf mentioned this before. He mentioned this indirectly, this Alliance for Industrial Data Edge and Cloud on the European level, where we're really looking at the continuum from edge on device up to the cloud. And you can imagine that a lot of standardization topics, and for the edge and the data value, I will dig in a little bit later. And this, we have a lot to do, and we can also a lot providing this. And think about my words. For sure, we have to do this on a global level, but we can influence this with an European perspective, because we can cover several elements and for sure several domains. When you're looking this and putting this somehow in an overview about initiatives, data-related initiatives in Europe, you have this overachieving IoT topic for sure. You have the basis infrastructure. Gaia X was from I think from Martin from Fraunhofer mentioned about taking care for data infrastructure. You see on the left side this wheel, this data wheel from BDVA, where we're looking at different aspects for data handling, portability, up to trust, like before. Then when you're going up to the topic, you have also this vertical specific initiative. And overall, we have to look when we're speaking about standardization. And I think it was one of the colleagues mentioned before this example, I think from NEC was this regarding this automotive example with Catena X. We are speaking about production data spaces, mobility data spaces, and the connection between this, where you're again immediately facing a lot of standardization topics, modeling topics, and so on. So this is somehow to give you a feeling, and maybe you're asking here why we have this blue circle here in the middle, and we are just on the way to have some kind of alliance between the association, open also to others, to drive this together forwards, because collaboration make it inclusive. Let's say it's also, like you can imagine, inside my heart. And here on the right side, you see the respective initiatives. IPSAI, for example, was mentioned from Klaus before, from Rolf before. The alliance I just mentioned, but you know how this can relate to each other. And I think, but this obvious standardization, looking at this in a holistic view, is key. From the communication, from the modeling, quality, interoperability, up to the aspects like trustworthy topics, data value topics, and so on. That's somehow the view we are inside. Now I have one slide inside how this can, as an example. As I mentioned before, I'm also vice president of the OPC Foundation. And in this case, and this was also mentioned before, we looked what is the IoT protocols. You see here the connectivity to different protocols, but like mentioned before. But, and this is coming more and more important, which you say in the middle, is about the modeling of the systems, the sensors, the robots, don't ask me, the machine tool, and so on. And I have the link to this, because overall, and this is one example, I know in other domains could be different, how we should bring the topics with the trustworthy aspects together. When you're speaking about edge computing, and here I just showing one slide about edge topics in order to give some kind of food for thoughts, what from our perspective the future of edge computing can look like. And the light green boxes are, let's say, some standardization topics which to address for sure on a meta level. You see it from the, when you're looking at the sensing quality, you know, we have here the sensing quality of data to assure the description for the seamless integration of devices. Think about more words about the companion specs. Yeah, no, also as a continuum, you see it here, edge cloud continuum is mentioned about this modeling, how we connect the devices. This is somehow the unified device management, how we ensure this trust, zero trust model mentioned for security. And but this was in depth, very good described for the speakers before about 6G, 5G, latency, low latency, and think about also a word about the usage on the shop floor from 5G and the 5G ASIA example. So this is somehow only to give you some food for thoughts. When you're now going to the, and these are my concluding slides, when you're now going to BDVA, we have tried to formulate, let's say, a framework. You see it here. In the framework, you see here some kind of values. We know where we can build on ecosystem, and we have the technology part, which you see in the lower box. As meaning we're looking at a holistic view and think about words. We're looking from data value, quality of data, up to trusted aspects. And that's the reason why we file this here. And when you now dig into the document, then we're looking about rules for data protection in the dynamic environment. Only look at the yellow marked topics. We are speaking about trustworthy aspects. We are looking also about, because we have to address also different verticals, also from agriculture, health, up to manufacturing, only to topic from the sensing and perception part. And we have to look here also in this cloud edge continuum. This is very brief and a short teaser, only to give you some food for thoughts regarding standardization, maybe with a little bit more dig in the edge part, also stressing a little bit to the level how the trusted AI topics which we have to look inside, and giving also a feeling, hopefully, what we can do, let's say, together, because we have the knowledge about this, and we can drive this jointly in an international standardization bodies de facto, like OPC was one example, or let's say consensus-based, where you have the classical standardization body. That's all from my side. Many thanks.
Thank you very much. Very clear and to the point. Thanks very much, Thomas.
It's a pleasure.
Then I would like to give the floor to Mr. Klaus Vechter.
Yes, you should hear me and you should see the slides already. Is that true?
Yes, yes, I can
Perfect,
see the slide.
perfect. Yeah, I'm coming a little bit from the other end, and I try to take you with me to a journey about building automation and what this has to do with IoT and edge computing research and standardization. First of all, let's check. Maybe I have to do it this way. Yeah, this is a little bit the topic. So I'm talking about IoT, about all these different protocols we are currently using, and even then about edge and some conclusion. So in IoT, this is really important for us because we're a global provider of IoT solutions and devices, and we are already involved in really various standardization activities around the world. So it's clear that the transformation of classic OT to IP is one of the topics. Then it's also clear that we need to improve in these horizontal requirements like privacy, security, and all these things. Then very, very important is circular economy for us because the energy consumption of buildings is still high. It's 38% globally, and we have here a good opportunity to lower that. So if we do it right from the beginning, yeah, here I like to show what we have already done. So as you see here, we're coming from a traditional building with very local switches and on-site services. Then we started automation. Then we are already in the smart building phase. And the next level will be what we call a collaborative building with self-adaptive operation and prescriptive maintenance. And this is clearly only done with IoT, with edge, and with cloud. There is no other way to make that happen. So that's the challenge, that's the road. What we have done already, for example, BACnet, we have a high use of BACnet in over 60% of all automated buildings worldwide. BACnet is used. We have changed the BACnet standard to the new BACnet Secure Connect specification, which is much more IT friendly, which is agnostic to IPv4, IPv6, which is able to use DHCP and all these things that was not possible before, and it's secure. So that's already established, that's already done. Somehow a little bit the same for KNX, also a very, very interesting protocol used mainly in Europe and in Asia, a little bit in US in the moment. There's a new specification, KNX IoT, which could be connected to the installed base by a gateway, and the gateway does not need the hardware. It's a function running on the edge, running on the cloud, or running on a, let's say, a little bit bigger device. So also here, a lot of things already done for the next decade. Then Matter, you might have heard about Matter. This is the thing driven by CSA, former Zigbee Alliance, mainly driven by Google, Amazon, Apple, Schneider Electric, and also us, also Siemens. We will see Matter in the middle of the next year, coming also to Europe. So also here, a very similar architecture as we have seen before. All this is also based on Thread. So Thread as the underlying Wi-Fi for the small system devices, mostly battery-powered devices, but all on IP. So that's the key. We believe that IP communication will help us making all these things possible, because we can really do end-to-end security from the sensor to the cloud, which is important. Thread is, in the meantime, supported by a lot of applications, as you see in the picture above. Then we have already established a liaison of the associations. It's called IP Bliss. This IP Bliss liaison of, in the moment, 6 application protocols is really driving the use of IP in building automation and for lighting, There will be a webinar in the next weeks if you need to know more about it. Then let's go to the edge. On the edge side, it's clear that it's important to shift the data handling from the network to the center of the edge. So we need to have the data available all the time and not somewhere in the cloud. That's really important because this data needs to be analyzed even in the building. So what we see today, there is some devices already available using the data from the underlying devices in order to store them and to analyze and evaluate them, or used to make a staggered distribution of software updates. We're talking about several hundred IoT devices, for example, in a hotel or in an office building. So you need some intelligence there, and you need such an edge device level. Anytime we talk about that, we see that there is a risk of creating a new silo because of missing standardization on that level. So here I'm really looking forward to the discussion later on, because I already heard a lot of interesting things in the other presentations. So what we really need here, we need interoperability between all these edges of the different devices. We need even interoperability about the underlying devices. So what kind of protocols should be, let's say, mandatory somehow in such an edge device for building use. So that there is a kind of, let's call it de facto standards, I will show a little bit later, we are using today, but that's not the end of the story. So here, for example, what we see, so clearly all these already updated protocols, they are really prepared now to be used in such a infrastructure together with the thread network, thread mesh network, which helps a lot, for example, to the EBBD or the Green Deal renovation wave. We have to refurbish and renovate all the buildings to reach the 2050 goal. And therefore, in a lot of cases, the existing cables could not be used anymore. They're broken, they're in a bad quality, or they're simply the wrong kind of cables. And this could only be done with a really reliable wireless infrastructure. And this is exactly why we have already decided to use thread for that. And as you see here, that could be such a scenario. But that's just a snapshot in history. So this will for sure even change a little bit in the next 2-3 years. So as a conclusion, in a smart building today, a user has already a lot of opportunities. So he could use his mobile for the way to work, book his parking, have a seamless access, will find his desk, and so on and so on. So as you see here, so this is already reality. The smart buildings already offers a lot of such things, but to do this all, you need all the data available all the time. And you need to have all these devices secure. So security updates will be more and more an issue in the near future. So what we need here is we are clearly looking for others from the industry. They're willing, together with us, standardize the edge from a functional point of view, because the technologic things are already there from our point of view. There might be, as we already heard, a missing MQTT binding. It's the same for BACnet, for example. There's a discussion about BACnet over MQTT. But anyhow, that's details. I think that the main thing is we need to standardize together the functional level of the edge, and then we can really use it, and even on a global way. And therefore, we have to do it on the European side, but we have to invite the US guys, the Asian guys as well. The standardization should really be focused on a global level. So thank you very much.
Thank you very much, Klaus. And I think very important information that you gave, in particular related to the need, for when you want to have renovating buildings, then you need wireless, to use wireless. Thanks very much. And Edge plays a very important role there. Thank you. Then I will need now to show the agenda again, because we'll change the part of the session. Sorry for that. So you see the agenda again. And this part of the session is, as I mentioned at the beginning, is a panel discussion session. And the main question and of course there are a lot of sub-questions that could be derived from this, but it's what are the key priorities for IT and edge computing standardization for industrial IoT, telecommunications and automotive domains. And the members of this panel will be all the speakers from the previous part of the session, but as well Mr. Gael Blondel and Ms. Ruda Sofia. And then, as I mentioned at the beginning, each of you could provide a presentation of 5 minutes. So Gael, please, the floor is yours.
Yeah. So I have prepared a few slides, and here you go. Okay, so just very quick, because 5 minutes is short. So that my point today is to think about open source as a platform for IoT and edge, and that's how we see the architecture at the Eclipse Foundation. So with constrained device, the edge device, IoT, and then up to the cloud. And you can see below here that we have the protocols, connectivity, security, which are really major cross concerns. And just about open source and standards, I think that it works in two directions. There is sometimes we have a code first approach with an open source project that potentially goes through a de facto open specification and then is standardized. And we have also open source reference implementation of standards defined and published by SDOs. So that's just to give you an overview of the fact that at the Eclipse Foundation we have standards, reference implementations of standards that come from different places. But this is where we talk about components, protocols, and that enables interoperability. But I would like to mention one concrete example, which is going from projects to a platform, and that's something that one of our members is doing pretty well. That's Bosch, where Bosch Iot Suite is based on Eclipse IoT packages that integrate all the previous connectors, and adds on top of that several open source projects that are also provided by Bosch as products based on those projects. So previously we had a presentation about digital twin, and typically here we have some good open source projects about digital twin. But to conclude about my two approaches between open source and standard, I just have two slides. This one is how to go from the code to standard. So at Eclipse, we have some projects that use what we call the Eclipse Foundation specification process. And that's what we use to define the industry consensus specifications. And that's really a code first approach. And that's really, okay, let's get adoption, but let's also ensure compatibility through these shared specifications. And the example of open source standards that become international standard, I think that MQTT is a very good example. It was an IBM and Eurotech project initially, and then it was open sourced, and later it was standardized. We have other examples of open source projects that become ISO standards through the GCC1 process. And from my perspective, the main goal is standards bring the security of regulation. And in the other direction, I think that more and more SDOs see open source as a way to gain visibility and adoption. But that's something that is very important from my point of view, is really to stick to the definitions of the open source initiative. And the open source initiative defines some requirements about open standards. And these are those 3 requirements. I will not read it, and maybe we can discuss that in the panel, but that's something that is really important, because that's really what enables a good and plain open source implementation of an international standard. And that's it for this short statement.
Thank you. Thank you very much, Gail. Thank you. Then I would like to give the floor to Ruti.
Okay, so let me share my slides.
Please.
Okay, can you see this?
Yes.
Okay. So, okay, so as Georgios explained, my affiliation is with Fortis, a research center institute in Munich, but here, so where I had the Industrial IoT Competence Center, here in this presentation, I'm going to briefly speak about the cooperation and support action UIoT, and in particular the work that we are developing in terms of standardization and open source aspects. So this corresponds to work package 3. So UIoT is coordinated by Martel, by Bonica Listi, whom you also know, and serves and helps in serving the projects of ICT 56. And we also interact, of course, with other CSAs that relate with IoT and Edge, and also with a set of SDOs. And in regards to work package 3, which is led by me, Fortis, what we are doing is we are working on 2 different aspects. So the first is interaction towards standardization, supporting the projects towards standardization, creating engagement, but also towards open source. So, and specifically there, so the cooperation and support action has started so last year, so 1 year ago, October 2020. And during this first year, our key actions have been in these 2 fronts: open source standardization. Open source is exactly what? Creating a catalog of projects that are based on open source. So what we are trying to do as a CSA is assist a little bit in the coordination and better understanding of the projects towards the tools that we have available in Europe for IoT and the Edge. And so on the standardization part, we have been also doing a similar work, which means collecting SDOs and mapping them based on a specific methodology. So specifically, what is the methodology? So here you have some steps that we are taking. Okay, so what is the methodology that we follow? We are covering different areas. So this means working and collecting SDOs, associations, consortia related with both consumer and industrial IoT, edge aspects, going to the broader SDOs, so ITF, IEEE, ITU, ETSI, etc., but also trying to address consortia that are relevant and associations that are relevant. So we are also cooperating with other CSAs, as you can see in this slide, OpenDEI being one example, and also collecting additional information. So in terms of the mapping, what we decided to do this year, so we could do this mapping per domain, as has been discussed here, so manufacturing, agriculture, etc. We have decided to start first by focusing on an end-to-end perspective of the IoT ecosystem. So this means that we have adopted the structure that you see in this slide: human, IoT interfaces, far edge, near edge, the infrastructure part, more focused on the telecommunications aspects, and data spaces. So here, this is an example which we feel so far that has been working quite well. It allows us to, together with the projects, to understand a little bit where are the projects focusing the most, where can we help better in supporting liaisons to standardization. An example of the collected data that we have. So this data that we are collecting will be available soon in the NG IoT initiative website, so ngiot.eu. Right now we are creating, let's say, a list so that, for instance, a project can select based on a specific area, the areas that you saw, okay, near edge, far edge, infrastructure, interfaces, can have a better understanding of the STOs that the projects can interact with. So we have been doing this mapping, but we have also been in interaction over the last year with the projects, and what we feel is that in order to increase interoperability and discussion, one aspect that is missing is a better focus on in terms of contribution. So where should the projects be putting a little more effort in terms of standardization, and why? Okay, so this is my last slide. So it gives you an understanding of a few aspects that we are doing or completing right now until the end of September. So this open source catalog will also be available online. It currently has over 100 open source projects collected in alignment with the 4 scope areas that you saw: interfaces, near edge, far edge, infrastructure, and data spaces. And we are doing the same as said. So in terms of STOs, we have collected over 60. This means STOs, of course, pre-standardization, associations, consortia, focused on industrial and consumer IoT. And we are also currently finishing a deliverable, which will be public with this information, and also with feedback from the projects that we are cooperating with, the research and innovation projects, with a set of recommendations by us, the consortium, and also by these projects. There are also some white papers being released, one focused on the open source ecosystem, as you can see, another focused on the decentralized vision and explaining a little bit where the projects are providing feedback. And we also, as CSA, organize a few meetings that are smaller in nature, but more that ignite discussion together with specific STOs and RIAs. Tomorrow we have one with the RIAs involving Antonio Kung and BDDA Dairo. Thank you, Giorgio.
Thank you very much, Jose. Thanks. I would like to thank all the speakers and panelist members for the presentations. And now we'll start with the discussion, part of the session. So if you'd like to put your video on. Thank you. So before starting with questions, maybe it's good to look at the chat. So there was a question, I think for Krista, you already answered, but maybe it's good to give an answer now. So the question was, how can we ensure liaison between all the different initiatives and alliances, so we get interoperable solutions, for example, in the case for the automotive sector, and also with other initiatives and topics related like data. So Krista, please.
Yeah, as I think it's a great question, and it was covered a bit by Klaus as well, and I relate very much to Thomas' presentation as well. I think it's a very tricky one, and as I said in my presentation, I'm not sure that you shouldn't decide that this is the alliance or the association that shall work on this, because everyone have their sort of problem domain to handle. The issue we see, of course, is that there are so many different organizations, both in connected vehicle and in, I mean, edge compute. It's tricky to even understand how many there are. So I don't have a final answer. I think we should need to work more on this. And I think that what we try to do in AEC and of course in other organizations where I'm part of, like 5J and others, we are trying to seek liaisons with the corresponding organizations. And I saw a few ones that I will reach out to today, for instance. Yeah, I think we have to work on our problem domain. We have to find solutions that work for the use cases of importance, but we need to bring those for review in some way. I mean, it has to be reviewed by other organizations and say that, you know, we agree that this is a solution to solve this problem, but it's also horizontal, so we can use it for other issues, and so we don't end up with a fragmentation in the infrastructure. It goes for, you know, we have to have an end-to-end solution that works from the device to the cloud through the infrastructure from the telco providers, the telco vendors, the cloud providers, the cloud vendors. It has to work for, and it can't be specific for one industry, one use case. I mean, we can't deploy 10, 50 different systems. It has to be aligned. And that is where the SDOs are important, of course, 3GPP, ETSI and others, that we get to, you know, that we have standards that we can lean on, but also that we can do blueprints of the standards, making sure that this is the, you know, a blueprint that we follow when we do connected vehicles. There might be another blueprint that is followed, or slightly different blueprint that we follow from an industrial and manufacturing point of view. So it's difficult, but I also struggle with the amount of organizations that I need to keep track of. So.
Thank you very much. But I think also what was mentioned previously in the presentations, I think the multi-actor and multi-provider approach, and then also looking into what is important for the user, and then try to bring this together in a blueprint as you mentioned, is important. But of course, there's a long way to go there. Any other comment on this question from other colleagues? Yeah,
maybe to add, you know, positively spoken, you know, when you're looking at Rupe's presentation, where you split very nicely from the far edge to the infrastructures to the data spaces, putting in the activity groups of residents this way, including standardization bodies. You know, we have also a feeling what I have tried to show, what is the technology stack regarding data-driven topics. As a meaning, we have somehow a feeling, a framework. But to be honest, I think, Christa, this was also in your mind, so one fits all. Oh my God, this would be very difficult because we are speaking about domain dimension, technical dimension, and shift, because we are now going into digitalization area, IT, OT, I think Klaus, you mentioned this. And here we have to think about how we're setting up. I have also not a silver bullet in my pocket, but positive, because when you're looking through all our presentation, we have some red link, everybody from us knowing some pieces, and maybe when we taking care for this so we're covering maybe 80% or 70% from the landscape. I don't know much. I will not touch precisely on it, but I think this is a positive topic. Only that my comment on this.
Thank you very much, Thomas. Then I would like to continue with other questions. So I would like to have a question that is actually, you know, an important part of the main question of this part of the session. So what are the key priorities that your organizations is or will be using to support the IT and edge computing standardization, including open source, for industrial IoT, telecommunications, and automotive domains? And then to add to that, because you mentioned already, you know, some topics in your presentations, to add to that, what are the barriers and what are the supports you would like to have if there are barriers on this. Please, then I will start. Let's start with the Rute first.
Okay, so speaking on behalf of my organization, in the sense of the CSA EU IoT, I would say that in terms of priorities, what we see as, let's say, a priority, so research-wise and business-wise, is so the need to bet a little bit on open source frameworks, as Gael also mentioned, with a concrete value proposition, of course, because of course we need to create the framework that assists industry in understanding the value of betting on specific open source models. So the Eclipse model is an example, a nice example, as Gael showed with Bosch. But our take is that we need to bet a little bit more on that, because that's normally, if we look into our counterpart in the USA and edge computing, that's one of the things that has made fog and so on a little bit more robust. So this means that we would have to create adequate frameworks together with industry to understand how to best position this. So this will also lower the barriers that we have today. So we have been hearing about MQTT, etc. So lowering a little bit the barriers that we have in terms of interoperability, going beyond the protocol interoperability. Another aspect that we would like to see as CSI, or at least we are trying to understand and collect and see if this could be interesting, would be a bet on experimental facilities for the edge. So currently in Europe we have one, I believe, so academic EdgeNet. So I'm not speaking about just test beds, but really full-fledged facilities as we had before with Planet Lab, for instance. That could help a little bit in the interoperability aspect, I believe. Thank you.
Thank you very much. Then I'll move to Mrs. Nurit Specher.
Yeah, hi. I'm sorry, I was disconnected by mistake for a short time. So so let me provide our perspective. So first of all, we believe that it's important to have a unified and harmonized approach to minimize to leverage and ensure alignment and synergies across the different activities. Too many standards which are not aligned and not leveraging synergies actually put some barriers for adoption. One need to select which one will win, and you cannot implement it all, so you limit your business opportunity. We also believe that so harmonization and alignment across the industry is important, to have a unified platform, to have a unified exposure framework such that we will provide common practices to the developers of the applications, how they connect, when they connect their network, their applications with the network. We believe that we need, of course, to address all the security aspects to ensure that we have native security in place, to have adaptive and secured framework with correct isolation, appropriate isolation between the applications and the components, to have appropriate access control, to control the exposure and the external to external consumers. We need to apply trustworthiness framework with different levels of security control based on different security contracts and addressing the different requirements coming from the different industries and different nations. And of course, to ensure data protection, privacy, confidentiality, and integrity of the data. And then another part that we believe that we need to touch is the data itself. Today there is tsunami of data, and the idea is how we can intelligently take this data that matters and analyze it and extract out of it some meaningful data that can really help to optimize the IoT applications, to optimize the network, etc. So this requires a little bit more thoughts and more research here. And I think one important aspect is to include all key experts from the different industries in the industry telco and bring them together to the discussion, to understand the requirements, to understand the needs, to understand the opportunities in order to ensure that we can build a solution that can attract all and can be adapted by all the different parties.
Thank you very much, Nurit. Then I would like to give the floor to Krista. Is Krista Bobber?
Right. Shortly, I think, you know, this was also discussed now on the chat here. I think there is a priority now in general to get, you know, the whole infrastructure in place. I mean, when we look at ACC perspective, I mean, we focus on what we call the automotive OEM business from that perspective and an application perspective. So that means basically using the data generated by the vehicle to build new type of services for data providers and partners, which was also now related to Nurit's speech here. So, I mean, we assume that, or the data generated by the cars are assumed to be consumed by a large number of actors, and you know, it even creates more value over time than selling the car itself. So it's a huge area. And if you look at our vision, really, from ACC, it's a future where we say all connected vehicles can deliver the full benefits of big data, enabling intelligent driving, improved safety, increased efficiency, and greater reliability. In order to achieve that, we see basically 3 steps. I mean, first of all, we need to get the standards and the standard blueprints in place or agreed, and that includes identifying gaps. And at that time, we also need the actors, including the telco providers, mobile network operators, and the cloud providers to be involved. Step 2 is to get this infrastructure in place. As I mentioned before, I mean, connected vehicles are heavily dependent on that the infrastructure is there where you drive the car. So we you know, spot the coverage is really a big problem for connected vehicles. And that requires also the actors here to deploy what we recommend, of course. And then very, very important is to have these, what we call the data consumption, data sharing models in place. That is one of the key aspects. And then there's a lot of details, but that I think is the overall statement I want to make.
Thank you very much. Then I would like to give the floor to Mr. Klaus Werte.
Yeah, thank you. From our perspective, we see it a little bit difficult or a little bit different to what we have heard now. So just as an example, when we talk about analyzing data and how to do that, we strongly believe that when we already enrich the data in the communication protocols like BACnet, KNX, OPC, or whatever, then we will have the right semantics there. Then it will be much easier in the end to analyze this data, or even to map between different applications with a mapping ontology and get a much easier use of this data for the customer. So we are missing a little bit standardization on that side. There is SAREF, there is Haystack, there is Web of Things. So here we need to also look which kind of standards we want to drive here, because without that we will not be successful in edge standardization as well. So we really need to see more the big picture, and then to address who should do what. Another issue I really hate, meanwhile, is that any standardization group came up with the topic of cybersecurity. But that's not helpful. If we have the experts, for example, in IEC 62443, they really know what they talk about, and they really establish things we can use. That's helpful, but not every little group dealing with any aspect now adds a chapter about cybersecurity. That's the wrong way. Really, we need the experts doing the job there and be focused. Then we will be successful, and then we will get it in time. That's another issue. Another 5 years for a CEN or CENELEC standard is not acceptable by the industry at all. So that's so far from my side. Thank you.
Thank you very much. I would like to give the floor to Mr. Gael Blondel.
Yeah, so that was already mentioned, but from our organization perspective, that's really about creating open source platforms. And to create open source platforms, I think that one of the main elements is that one of the motto behind the success of open source is don't reinvent the wheel. And I think that applies to open source and also to standards. So I think that European funded projects should not only explain what is the innovation they bring to the table, but also how they adopt existing standards, how they leverage existing open source platforms, how they extend those existing open source platforms. I think that also one point you were talking about the barriers and what kind of support we need. I think that we need to promote open source as a valid exploitation strategy. We have open source and standards are sometimes not fitting well together for one reason, that is that we still need some education or some to improve the culture, and that's on both sides, in my opinion, because I know that lots of open source activists, for example, are against patents, and I think they are wrong. And most IP lawyers are also often the main advocates against open source. So that's really and this meeting today is a very good step that we are all around the table. But that's really starting with designing open source platforms and gathering the body of knowledge from existing standards, and potentially finally contributing to new standards from what we have experimented in open source. That would be our approach.
Thank you very much. And then I would like to give the floor to Thomas, but then with an other question, and maybe you can also mention the previous one, but what are the means to simulate the alignment of the results of the European Commission funded projects with IoT and edge computing standardization, including open source for industrial IoT, telecommunications, and automotive domain? And what can your organization do to stimulate this alignment? And then also in that context, what kind of standardization work could a research project undertake? Can research projects work together? So there are many sub questions.
Let's try to give an answer. Maybe I will focus on 4 topics to answer this a little bit on the needs topics, and then of course how we can stimulate collaboration and what is the research aspect are. But maybe to hit on or to put on what Gail is saying, I give you a feeling regarding OPC. We have changed in the OPC the model to open source standardization. We used RAND set, this is reasonable and non-discriminatory zero license field. There's a set at the end. We are starting where we have the proprietary model with 200 members in the organization. Now we are above 800. Only to give you a feeling, when you make it in a clever way, then you can, in a positive sense, penetrate the market. But this was a topic. So sorry, only Gail, to give you one example. For sure, in OPC, we have not the classical open source process used, but nevertheless, we put it open source. Let's phrase it in this way. Second topic, what we can do also, I think we have really an impact-oriented way to collaborate. Maybe, I said this before, we have some nice framework shown, for example, from Rute, setting up an appropriate and efficient process. Efficient meaning that we not have the super duper organization, but an efficient exchange, because partially still also when the verticals are collaborating in the area, partly when the cooperation are overlapping a little bit in the areas, that's not a problem. But we have not, like Klaus said, that everybody is making the same topic. I think this would be some guideline, and I have said before also not the silver bullet in my pocket. And last but not least, only to cover the third aspect, and to be honest, the rest of the question, I'm not aware, it was a huge bunch. What can research do? Yeah, I'll give you an easy example. When you're speaking about AI, when you're speaking about machine learning, when you're speaking about functional safety, and when you're speaking about a system, a machine, a train, which we have to fulfill functional safety or machine regulations, and now you have a machine learning algorithm inside. What we have to do really to guarantee, or guarantee maybe is wrong, to ensure also the request from functional safety. I think this is a topic where research is heavily needed, how we are doing this. And let's say to the, and for sure the other topic is regarding the modeling. Klaus, you mentioned there's a lot of modeling is ongoing, INT is ongoing, but there's a higher level on top. And last but not least, when you're speaking about trusted AI, how we are doing this, how we make it visible, you know, there's a VDI and a discussion about a very easy trust label, which is orientated to the energy label, but to make to society visible what AI system, how is this proven, or certificate is maybe a wrong word, or maybe too forward, how can we do this? All in the context, think about the risk classes in the AI Act. This is, let's say, where research, how is this influence safety, what are future topics, modeling, and for sure in the AI area, how we make it visible, also testable, what AI class or AI system you are confronted with. That's my 2 cents.
Thank you very much. Question. Yeah, thanks. Yeah, regarding the research and standardization, as you mentioned, there are some topics like AI and trust that's important to take into account. Then I would like to put the same question to Ronald front about the relation of the standardization and research. How research could contribute to standardization, and how maybe standardization could contribute to research. I mean, how researchers could use the standardization, specifications. Please, Ronald.
Yeah, thank you very much for this question. So I think in general, we have to speed up the implementation cycle for different use cases we are discussing now, or we have discussed in the part. I think these open source discussion is very important, but of course, respected to a specific use case, I think we have to close the development cycle, starting from standardization, doing a reference implementation, doing a proof of concept in a ecosystem or in a test bed or test environment. And that, I think it's a good time to follow up with a blueprint to discuss this with industrial partners and the end users, and then going back to the standardization. And I think in those cycles, we have to address the different possibilities for the different stakeholders to get a refinancing of their effort they are spending in speeding up the development cycle. I think in the past it was very important for Fraunhofer or also for the HHI to have a refinancing coming from patents, from the video coding or from the 3G PPP. I think we have stronger discussed the possibilities and how to get refinancing also for the research institute when we are going to open source or open platforms, how we can address this in a closed cycle as I has described.
Okay, thanks. Thank you, Ronald. So there is a need also for the cycle, as you mentioned. So in that line, can we say that maybe strategies somehow needed, or some discussion on kind of strategy on how, how research could influence standardization the other way around? So who would like to answer this question? Martin, can you start?
So, I mean, I think there's an important interaction, and as you see in the case of NGS-ILD, there has been a kind of cycle also. But what we have to look at is that this is also done at the right time. And so what doesn't work is basically that research project develops something new. In its third year, it says, oh, we should go to standardization. It shows up one time, presents the results. Everybody says nice results. The project was never seen again. Nobody picks that up. So that's a thing we've seen a couple of times in 1M2M, and that doesn't work. So what does work is if you have a longer term thing. If already at the beginning of a project you maybe have some overlap of the people involved in the project and involved in standardization who are aware of that. If that is aligned, then there can be contributions. Of course, it also depends on what kind of the contributions are. It's more easy to maybe have kind of high-level things, use cases, requirements, some kind of high-level knowledge or expertise, as we did in the kind of with AITI on the semantic interoperability and ISO IEC JTC1 SC41. We had some something you can do that. But for more technical stuff, you need proper contribution. Most things are really contribution driven. It needs to be done over some time. If it's international standardization, it may also be costly because you may have to travel to different places. So you need to look at this overall thing and do the right things at the right time. So what's not sufficient is if you develop something and then just try to throw that in, but there's no follow-up, the project is over, there's no funding after that. So either if that's done from project side, this needs to be taken into account, and there needs to be some follow-up. In other cases, it will be taken up by the people in the project, but we'll do that for their organization after the project is over. So I think a lot of things have happened after that and are never credited to the project. But yeah, that so people need to be aware.
Okay, thanks. So from my opinion, more discussion is needed to create some kind of strategy on this cooperation, on the efficient cooperation between research and standardization. Who has some other comments on this?
Maybe I can comment. From my perspective, we are working to incorporate and work very closely with different research constitutes and projects. And this is very, very important, right? Because many of the topics are still, they are still subject to additional research, and important that they understand the need, that we get the information, and that we work in close iteration with the research work, by the way, also with the open source, of course, which is the reference implementation. And what we actually also do is that, first of all, as part of ETSI, we allow them to be part of the members of the groups, of course, and participate in the discussions. We run hackathons that they can actually also play with that and provide also feedback and feed information back to the standardization work. And as I said before, it's very important that we understand the landscape, that we understand what is available, that we avoid duplication, that we are understanding the gaps, and that we communicate them, and we work in close cooperation here.
Thanks very much, Nurin.
Maybe just if you allow me one more comment. There was a little bit a comment before about unification, etc. I just wanted to mention that thinking about this, actually the unification should not only happen across the edge, but across the network in general, because some of the information or some of the IoT platforms can run also in the centralized location, not only in the edge, right? we need to have a unified way how to create this intersection between the network and the IoT platforms and the industrial applications, etc. And this is something that we really need to work on to ensure that we have unified exposure framework across the network end to end, that we have common mechanisms and practices how to approach, how to connect these two worlds together, and understand the requirements, understand the needs of the different industries, and try to provide the solutions and close these gaps.
Thank you very much. And a last comment before giving the floor to Mr. Rolf Riemenschneider for the conclusion.
So, Georges, I would like just to say two things. Okay, so in terms of the relation with research and standardization, so we have a great example on the internet, which is the IETF and the IRTF. So I think that perhaps looking a little bit into the models that they have that are slightly more open than some of our SDOs, so it would help. So their research and industry do work together, not just participating in groups, but in a voluntary way. And what we see, unfortunately, in the projects is that contributions there are low. So I think there is one problem that we feel at CSA is the lack of awareness of where the projects can contribute. So it's not just the fragmentation, it's lack of awareness. So that lack of awareness can be improved, I would say, or fought back with training, with adequate training. So the researchers are entrepreneurs. Ronald also mentioned the need for a strategy that takes into consideration all the aspects of an innovation cycle. Training should be part since an early stage, and support for that in projects, so that the projects could understand where to also position the results as a consortium, and not just based on the individual organizations that participate in the projects.
Thank you very much. Then I will thank you very much for a very good discussion. Very good for your thoughts. And I would like to give now the floor to Mr. Rolf Riemenschneider to conclude. So I'd like to thank you again all, and also the audience for the discussions, for at least in the chat, and for your for the participation. Thanks very much. So Rolf, please.
Thank you, Georgios. Can you hear me?
Yes.
Well, I switched to a meeting room. Thanks for all the speakers for the intervention and the interesting discussion. Yes, I think it's a midterm conclusion, though not a final conclusion. So what should I take away from this morning's discussion? I think actually we've seen a strong message from the cloud edge, leveraging European suppliers, European interest, more computing power at the edge, but building on the power of networks. So how to combine distributed computing on localized access networks. The ETSI-MEC discussion was very strong, benefiting from distributed cloud architectures. Yes, we know that we have strong suppliers in Europe, like from Krista, from Ericsson, also from Nokia. And there's a need to drive the agenda for standards in that direction. So it's clear that automotive services will benefit from consistent connectivity across 5G, ITS, G5, or satellite communications. And in particular, I think that was quite prominently presented in emerging cloud services. So we have to see, to keep control also and competences in emerging cloud services. Yes, there's a track record in standardization and a good basis for ETSI and GSILD. The HE-SIM, contact information management based on JSON LD at the edge, or the smart data model initiative from Fireware. So that is moving orchestration to the cloud to have a very dynamic data processing from the edge to the cloud, particularly important also for the automotive cloud edge, which is a hot topic at the moment, also with the discussion of automotive OEMs at the moment. Equally important to have not only digital twins for automotive, but also for manufacturing. And it's clear, that companies like Siemens have a strong interest in that, to have an evolving edge cloud shop floor ecosystem based on OpenCUA and digital companion specifications, an asset administration shell, and so on and so forth. In the discussion, it became clear that apart from technology, edge and cloud, I think there's a strong need for cooperation and partnerships related to trustworthiness, data protection in a dynamic cloud edge fog environment. There we need standards in order to benefit in harnessing any AI evolution or any AI intelligence, which is actually built in the cloud. So standards for AI and trust are missing a key building block as well as a baseline for harnessing future AI technology. Good. This said, yes, the transformation of classic OT into a connected and self-adaptive environment requires also a new orchestration for local edge and field bus networks. And of course, the complexity is quite large, but still the driving force, again, as mentioned by Klaus Wächter, is security. Security requires cross-layer cooperation and a dynamic environment for software updates and management, device management. Otherwise, the edge data will stay in a silo as we know it, for security reasons. So we have initiatives like Thread and Matter, who, apart using existing standards like MQTT and work on building blocks for converging building automation networks in order to make use of the edge data, which is seamlessly available locally at any time, but still needs to be processed and exploited. So there's a high risk, particularly at the automation edge, of deluge and fragmentation still. And we look at the scenarios for end-to-end security eventually of an IP-led network. And that is sort of completes and complements the discussion we had yesterday and the input we got from IETF. Quite clear as well that greener buildings require data exchange across different automation systems. Otherwise, we will not be able to have the next level of automation and the next level of services and bringing different buildings together. Finally, we also pick up discussion yesterday and bringing together open source and standardization. I think we took that as a takeaway, as an important step, and we have to follow that line. We need reference implementations for that. We need sort of what was said today, a blueprint for standards, and we hope to support that also in our open projects, particularly if we move closer to pilots and real environment implementation. So final comment or final question, is edge evolutionary or disruptive? At the moment, what I take away from this morning, correct me if I'm wrong, cloud is the safe harbor. There's still, plenty of innovation and exploiting the computing power and the cloud to come up with new innovative services and new applications, new ways of automate and control networks and environments. So the new opportunities ahead. Maybe that is the short-term, the midterm scenario. But this said, there's a strong need for trustworthiness and security, which requires cooperation partnerships of industrial stakeholders for the telecom, for the manufacturing industry, but also for buildings. That is my last takeaway, and I'm open for comments or feedback if I missed something or if you do not agree. Thank you so much.
Thank you very much, Rolf. Yeah, I would like to add one comment or related to the relation between research and standardization. There were some nice ideas on taking the blueprint and somehow having a cyclus, so that the research projects that take the blueprint, do work on it, and then go back to standardization. I think, and then people that work together that participate in the projects, it's also good that they also participate in standardization, and there maybe also some more funding will be needed. I don't know, from what Martin mentioned, to allow the participants of the project, in case SMEs, for example, to participate also in the standardization initiatives.
Yeah, but as you know, I think we're looking for strategic projects under Horizon Europe. I think that is our wisdom. And these projects allow for flexibility via cascading funds.
Yeah.
Either use cases or for application-driven scenarios, maybe bringing together open source components or, as you said, blueprints for standardization. I think there's an openness for that one. The way the project design, the open calls, that's in the hand of the coordinators. But with working with the Alliance of IoTI, but also with the other associations, we try to push and coordinate via the CSA, NG-IoT, for instance, and other CSA to push the projects in the right direction. So it's an open consultation process. Everybody is open to engage, and there's flexibility in the projects in order to have that dynamic process.
Thank you very much, Rolf. Thanks. I would like to thank everyone. Thank also Rolf and Anna. And Anna, I would like to give you the floor to give the last comments. Anna, please. And thanks. Bye from my side.
Yes. Already, I wanted to thank you so much, all of you, to participating. It was a really very fruitful discussion. A lot of very interesting feedback that to feed currently doing in NG-IoT, and we're going to try to convey this in a clear and synthetic manner. So thank you again to all the panelists and to the European Commission as well for the participation, obviously to IoTI for the great moderation.
Thank you very much, and I would like to thank again also the audience and also very much the speakers and the panelist members. Thank you. Bye bye.